alternate procedure, that is solutions for problems of rolling by using ground frame method. We can solve. So in this problem, if you analyze physically to check whether our answers are correct or wrong, we can check, and physical possibility of all these answers we have obtained also you can check. For instance, frictional force we have taken backward, we are getting positive result. Therefore, the frictional force direction is correct, and the direction of force of friction is backward. Our assumed direction is correct because we have got positive result. Alpha, we have got positive result. Therefore, our assumed direction of alpha is correct. Acceleration of the center of mass got positive result. Our assumed direction of center of mass is correct. If you alter the assumption, for instance, if you take or assume frictional force in forward direction, you take the force of friction in forward direction, how can you write the equations? What are the changes, possible changes? We have no change in kinematical equation, but net force is equal to, this force is positive, this force is positive. Therefore, instead of minus, this will be plus, is equal to ma. And here there is no change. Torque equation, in torque equation, let us see. These two forces pass through the center of mass, cannot produce any torque. This force, and this force. Three forces cannot produce a torque about the center of mass. This force will produce a torque, but in which direction? In the anticlockwise direction. You write the torque equation, tau c is equal to IC into alpha. Vectorially you have to write. Now this torque is anticlockwise. This is producing an anticlockwise torque. Torque is in this way. Fs is equal Fs into R. In anticlockwise or positive k-cap direction, we are getting the torque. When you just reverse the direction of static friction, that's equal to, what is IC? IC is equal to m r square by 2. That is remaining as it is. And alpha we have assumed in clockwise direction minus alpha k cap. Therefore, you have to use the vector symbol strictly. This gives us Fs is equal to minus m r alpha by 2. Instead of plus, we are getting minus here. So, alpha is equal to 2Fs by mr minus of this. A is equal to r alpha, equation number 1. A we are getting from first equation or second equation. Divide both sides by m to get A. A is equal to F plus Fs. Instead of F minus Fs, we are getting now F plus Fs by m. And alpha, how much you are getting? Minus 2 Fs by mr. Equation number 4. R getting cancelled, getting cancelled. And Fs is equal to minus F by 3. When you are changing the direction of friction, assuming the direction of friction forward or towards right, you are getting the force of friction negative. We have assumed in positive direction, but we are getting negative answer, which signifies that the direction of Fs is opposite to that of the assumed direction. Therefore, the frictional force is in which direction? Backward or towards left. In both the ways you are getting same answer physically. So this is the assumed direction, but actually the force of friction is backward. This is correct. This is wrong physically, but we have assumed this. We have assumed this. And we have written all these equations, force equation and torque equation, with this assumption. Instead of doing that, suppose you take the frictional force back, and here we assume alpha, opposite direction. You can have any assumption, doesn't matter, but equations will be modified. And what are the equations you can modify? Look, A is equal to R alpha. This equation you have to modify. I told you that when A is in this direction, center of mass acceleration will be in this direction, alpha will be in this direction, acceleration will be A plus acceleration of this point P. Now this is the diagram now. Alpha is in this direction. Kinematical equations you start. A plus R alpha will be equal to 0 instead of A minus R alpha will be equal to 0. Why? Because velocity of this point is equal to, suppose if you take velocity in this way, omega in this way, v plus r omega, and velocity will be equal to 0 for pure rolling. For pure rolling, the condition is that this velocity is 0 because the surface is fixed. Then we can just write, differentiate both sides to get A if you differentiate it, or you can just write like this. From the basics, derivative of this is dv by dt, derivative of this is r d omega by dt is equal to 0. This is the acceleration of the center of mass, and this is the angular acceleration of the rigid body, 0. Equation number 1, instead of A minus R alpha is equal to 0, you have to write A plus R alpha is equal to 0 based upon this assumption of anticlockwise alpha. Well, this is kinematical equations. Next, force equation, net force along x direction, that is F minus Fs is equal to m into A. There is no change at all. Along y direction, n minus mg, that's equal to 0, no change at all. Come to the torque equation with the force equation. The torque equation. Force equation means Newton's second law for translation. Torque equation means Newton's second law for rotation. Well, tau c equal to I c into alpha. You have taken alpha in plus k cap direction, you have to change here. And Fs you have taken backward, it will produce a clockwise torque. Alpha you have taken anticlockwise. So if you follow the vector strictly, you can write Fs is equal to again minus mr alpha by 2. And you have to put A is equal to minus R alpha. A is equal to minus R alpha, kinematic equation. Substitute Fs from equation 4. That's equal to minus mr alpha by 2. Therefore, alpha will be equal to minus twice the frictional force upon mr. You can put alpha from this equation here, and if you simplify, minus f minus r into alpha, again you are getting plus, and F minus Fs. Acceleration you are getting from the first equation to get this much. Alpha you are getting from fourth equation to get this much. Substitute alpha and a from fourth and first equation. In equation number 1, the kinematical equation to get Fs equal to plus f by 3 again. Plus sign signifies that, which signifies that the direction of Fs is same as that of the assumed one. So you can write the free body diagram with her own assumption. Write the force equation, the torque equation, kinematical equation, and follow the strict vector equations to get your answers. The answers they may ask to calculate the accelerations, linear acceleration of the center of mass, angular acceleration of the rigid body, the coefficient of friction required for rolling. Sometimes they may ask you to calculate the velocity, the linear velocity of the center of mass, the angular velocity of the rigid body as the function of time. We will do some problems asking all this. So when you get positive answer, your assumed direction is correct. When you get negative answer, just you alter the direction of the vectors, the force, or it may be acceleration, or it may be velocity in the free body diagram. Well, we can solve the problem by using ground frame method now. Let me explain the theoretical details of ground frame method. Let us consider the rolling body. Which rolls without sliding on a horizontal surface. Needless to mention, the surface is fixed. Let us assume that center mass velocity of the rolling body is v and its angular velocity is omega, is shown in the diagram. You choose a fixed point on the ground because this is called ground frame method. Let the fixed point be O, the origin is the y-axis, this is x-axis. We need to calculate the angular momentum of the rigid body about this point. The angular momentum of the rolling body about any point fixed with ground. Let the point be O. Is LO is equal to the spin angular momentum, that's equal to IC into omega plus angular momentum of the center of mass with respect to this point cross MV. See, Vc is equal to V. For pure rolling, or rolling without sliding, V is equal to R omega. And here these are all vector quantities. R cross MV is equal to R MV sine the angle between R and MV this is theta say, sin theta, and R sin theta is nothing but radius of the rolling body. So R sin theta can be written as R MV into R, and direction R cross MV. R cross MV. Bring the tails of these two vectors, MV vector and R vector. From R to MV, you bring the angle. That angle moves in clockwise sense. Therefore, R cross MV direction is clockwise, or minus k cap. And omega is equal to omega minus k cap. You substitute this value and this value in this equation to get angular momentum about O is equal to IC omega minus k cap plus MVR into minus k cap. Take minus k cap out and put V is equal to R omega as the condition of rolling without sliding to get minus IC omega plus M. Instead of V you can write R omega into R. Okay. This gives us, when you take omega out of the bracket, minus omega k cap will be common, IC plus MR square. This is none other than the omega vector, and this is none other than the moment of inertia about the lowest point of the disk. That is what we call instantaneous axis of rotation, as I explained you. Then IC plus M R square is equal to IP. So angular momentum of the rolling body about any point fixed to the ground will be equal to IP into omega. The angular momentum of the rolling body with respect to a point O is equal to IP into omega. Differs at both sides with respect to time once. dl by dt is equal to IP d omega by dt. D omega by dt is the angular acceleration of the rigid body, alpha vector, and this is equal to the net torque experienced by the body about this fixed point. That's very interesting. This is called Newton's law of rotation. With respect to the instant axis of rotation. or torque equation with respect to ground frame. And other equations will remain as it is. For the solutions for the problems of rolling with respect to ground method needs the torque equation to be written taking a fixed point on the ground, and net torque about this fixed point will be equal to the moment of inertia of the rigid body about the lowest point, or we can say instant axis of rotation. Here I phi is the moment of inertia about instant axis of rotation into angular acceleration of the rigid body. Velocity, linear and angular dotted line, accelerations, linear and angular bold lines, and forces. If you write the free body diagram, the forces will be bold arrows. Forces bold, accelerations simple arrow, velocities dotted arrows. So with this procedure, let us take the previous problem. Disk. The disk is rolling on this horizontal surface. Acceleration of the center of mass, angular acceleration of the disk, gravity, normal reaction, static force of friction, assumed direction. The direction I have assumed back. Let us write the force equation. The net force is F minus Fs is equal to ma. Along normal direction, n minus mg is equal to 0. As it is, no change. Torque equation. In this case, you have to take the torque about any fixed point on the ground. This frictional force passes through this point, cannot produce a torque, and torque produced by these two forces will cancel each other. How? Let us see. The frictional force torque is tau f, torque produced by the normal reaction is tau n, torque produced by gravity is tau g. About which point? About this point of reference O, that is equal to I phi into alpha. Frictional force passes through this point, cannot produce a torque, 0. Normal reaction produces a torque, let it be x. About this point, it produces a torque n into x in which direction? Anticlockwise sense. Gravity produces a torque in which sense? mg into x in anticlockwise sense. And torque produced by the applied force also we have to add. This force will produce a torque about this point. How much? F into this perpendicular distance. This is the line of action of this force. From this point, the perpendicular distance is small phi, that is none other than the radius of the rolling body. F into r in which direction? Clockwise. Why it is clockwise? Because r cross f. R cross f. This is f vector. This r vector. This is f vector. R cross f is clockwise. In this way, you have to decide the direction of torque. When you will be expert, directly you can write minus fr kf is equal to ip into alpha. For the disk, ip is equal to ip is equal to ic plus mr square. Parallax theorem and ic is equal to mr square by 2 plus mr square. You are getting 3 mr square by 2. So instead of ip, we can write 3 mr square by 2 into alpha vector. Or we have taken alpha in negative z direction minus alpha k cap. You can write like this. This gives us n plus n minus mg kf minus fr, or you can just write, remove kf from both sides, is equal to 3 mr square by 2 minus alpha. And Newton's second law of translation along the vertical direction shows that n is equal to mg. So n minus mg will be equal to 0. Therefore, these two forces are equal and opposite, and they are collinear. In this also you can say that torque, sum of torque produced by these two forces about any point will be 0. Directly also you can write this. So net torque is produced by the applied force about this point, and that's equal to minus fr k cap. So alpha will be equal to f by 3 mr. You are getting same answer. That is the answer. And for rolling, A is equal to R alpha. Under this assumption, this equation remains as it is. You can write this is fourth equation. So acceleration F minus Fs is equal to ma. N minus mg is equal to 0, or n is equal to mg. Well, and A is equal to R alpha, and fourth equation alpha is equal to F by 3 mr. So directly the torque equation about this point in this method gives us the angular acceleration. Substitute alpha here, to get A is equal to 2F by 3m. Positive sign signifies that our assumed direction is correct. Alpha is equal to minus 2F by 3m r kf. And substituting acceleration here, you can get Fs is equal to F minus ma. A is equal to 2F by 3m. This gives us F by 3m. Answer. In which direction? Since it is positive, our assumed direction of friction is correct. So in this way also you are getting the exactly same answers what we obtained by using the procedure or the solutions for the problems of rolling by using center of mass frame method. Or basic in these two ways. In these two ways, we can solve the problems of rolling. In center of mass method, torque is taken about the center of mass. In ground frame method, torque is taken about any point fixed to the ground, or you can take this point here also, but there will be a confusion. One point will be with the ground, another point will be with the rolling body. These 2 points may coincide, but these 2 points are totally different points. So better to take a point other than this point on the ground for the sake of clarity. In both the methods, you have different torques. Let us compare. Well, let us compare both methods. Center of mass method and ground frame method. The rolling body, here force is acting, gravity, normal reaction, frictional force I have assumed backward. Here applied force, gravity, normal reaction, frictional force, acceleration of the center of mass, angular acceleration, acceleration of the center of mass, angular acceleration assumed directions. Directions of A alpha Fs, A alpha Fs we have assumed. The force equation F minus Fs is equal to ma along x direction. Along y direction, n minus mg will be equal to 0. Force equations. These force equations both the procedures we have same force equations. Then torque equation. The torque equation and center of mass method, the reference is center of mass. Therefore, tau c is equal to IC into alpha. This is the equation. In this ground frame method, the torque equation can be written as tau torque about any point O on the ground, or torque about, you can take this point O here. tau O is equal to I p into alpha. Totally different. Here tau C is equal to about the center of mass, normal reaction, the applied force, gravity. These three forces pass. Therefore, they cannot produce any torque about the center of mass. The torque is produced by the frictional force. That's equal to minus Fs into R kf. Here the torque about this reference point fixed to the ground will be the gravity and normal reaction. They are equal, opposite and collinear. They are passing along same vertical line. Therefore, they cannot produce a torque about it. A frictional force passes through this point. Therefore, the static force of friction also cannot produce a torque about this point. The torque is produced by the applied force, and that's equal to F into R minus kf, as we have discussed. Well, IC is equal to, if it is disk about the centroidal axis along the z direction, IC is equal to m r square by 2. Here IP is equal to IC plus, here you are using parallel axis theorem. By using the parallel axis theorem, we can get IC is equal to m r square by 2 plus m r square, you are getting 3 by 2 m r square. So, this is IP, this is the torque. Substituting torque and moment of inertia in this equation alpha, you are getting minus Fr kf by 3 by 2 m r square is equal to 2F by 3m minus kf. But if you substitute here, we are getting alpha is equal to minus alpha kk. We are getting Fs into R is equal to m r square by 2 into alpha. This gives us Fs is equal to m r alpha by 2. We are not getting alpha by using the center of mass method from torque equation. However, in ground frame method, directly we are getting alpha by using torque equation. That's the difference. So, to get the alpha, we have to use the other equations, force equation and kinematics of rolling. That is given as A is equal to R alpha, and this equation also valid for both the methods. Both methods can use this equation. These two equations, force equations, kinematical equations, are common in both methods, but the torque equation differs. Substituting alpha here, we are getting A is equal to R alpha. We substitute alpha here to get A is equal to, these are the magnitudes. Therefore, you should not take the directions of negative I cap. So, 2F by 3, that is R, into R we are getting 2f by 3. Plus means our assumed direction is correct. If we substitute fs in this equation, we are getting acceleration is equal to f minus fs by m. F minus, what is fs? M or alpha by 2 by m. But A is equal to R alpha, or directly you can substitute A is equal to R alpha here to get A is equal to R alpha, you can use to get MA by 2. Now, this value if you substitute here, we are getting acceleration is equal to F minus Fs by m, or directly you can get the same answer. We can get the same answer. In both the procedures, force equation same, kinematical equation same. The torque equations are different, totally different. A torque equation in ground frame method will directly give you alpha, and using the alpha in kinematical equations, for rolling you are getting the acceleration, and you can substitute the acceleration here to get the force of friction, other things will automatically come out. And torque equation in center of mass method, you are getting Fs is equal to m r alpha by 2. R alpha will be equal to A. The kinematics of rolling, if you substitute, you are getting ma by 2. Once you are getting Fs is equal to ma by 2, substituting it in the first force equation, you are getting the same acceleration. Once you get the acceleration, this acceleration you can use in kinematics of rolling to get same alpha. Same alpha you can get. In this way, you have to master over both the procedures to solve the same problem of rolling.